8.5, similar objects, scale models, and scale diagrams. So example 1, are the two figures similar? And explain why or why not. So we know in order for figures to be similar, the corresponding sides need to be proportionate to each other. So we need to determine what the scale factor was from each. So here are the measurements for every side. And the corresponding sides would be 2.6 to 1.5, 2.2 to 1.3, and 1 to 0.6. Those sides would correspond. So those ones all need to be proportionate. So new over original, or image over your original object. So scale factor is new over the original, or if it helps to think of your image that you came up with after you applied it over the object that you scaled, either or. So this is my first shape and I scaled it to get this second shape. So this goes on top, 2.6 over the corresponding side of 1.5. When you divide those two, I get a scale factor of 1.7. The next two sides, 2.2 was 1.3, divide those two, and I get 1.69, which is 1.7. And 1 over 0.6 divided is 1.7. So because they all had the same scale factor multiplied to the original to get our second object, and the scale factor is greater than 1, which tells me that my second object was enlarged, which it was, then I know that yes, these shapes are similar because each dimension has the same scale factor. Example 2, find the scale factor of the following 3D diagrams. So scale factor again, image or your new one over what you started with. So I'm starting with this first one and then I get this smaller one. So because I can already see visually that the other one's smaller, in my head my scale factor should be less than 1. It should be a fraction, it should be a decimal, it should not be greater than 1 because I'm shrinking it. It won't be over 100% of the size that I started with. So image over object, or new over original, is 2.7 over 5, which gives me 0.54, which satisfies what we predicted. It is a reduction, or we've shrunk our original because my scale factor is less than 1 after I divided my new image over my original object. Example 3. Corey bought a toy tractor to give to her younger brother for his birthday. The dimensions of the toy are given in the diagram. The scale ratio on this package says it's 1 to 16. What are the dimensions of the real tractor that this little toy tractor is being compared to? So if it's 1 to 16, the smaller number is always going to be the smaller object as well. So my tractor, for every centimeter on my toy tractor, will be 16 centimeters on the real tractor. So scale factor again is image over object, but it's given to us 1 to 16, or 1 over 16 we know is our scale factor. We want to multiply our scale factor on the object to see what we'll get in real life. So each dimension. So you would take your normal object, because the scale factor is less than 1, 1/16 is not greater than 1. 16 over 16 would be equivalent to 1. So this is less than 1, which means it was a reduction. So the original was the large tractor, was your object. We started with our object. You multiply by your scale factor to get your image. And this is the image. We scaled down a live tractor to get our smaller tractor. The reason I know that, again, not that we got a real tractor from our scaled down toy, is because our scale factor is less than 1. I will not get a real life tractor if I scale down a toy tractor already. That'll be a very, very small object. So In order to figure out what your object dimensions were, in general, we would divide by our scale factor. So now to find our object, this is just how you would know, we need to divide our image, cannot spell, divide our image dimensions by our scale factor. So that's what we're going to do here. So 12.7 is our first dimension. 12.7 divided by 1 over 16 gives us 192 centimeters. So that's a larger value, which means in my real tractor, the height of that tractor would be 192 centimeters compared to the scaled one, which is 12.7. 9.5 divided by 1 over 16 is 152 centimeters. So the width of my tractor. And then the length of the tractor, which was 19.1, divided by my scale factor, is 305.6 centimeters. These are the dimensions of the original tractor. And example 4, a pipe has an inner diameter of 1.5 meters, a wall thickness of 0.18 meters, and a length of 2.5 meters. We want to draw a scale diagram of the pipe using a scale factor of 1 to 15. So again, my scale factor is my image to my object, or new shape or new object to your original. Whichever way makes more sense to you. So again, our formula is always your original object times your scale factor to get your image. We need to scale this, so we need to find our image based on our original given. So 1.5 times 1 over 15, and my scale factor again, 1.5 meters. So since my scale factor is less than 1, I should be shrinking. I should get a very small decimal here when I multiply by 1 over 15. I get 0.1 meters, or 10 centimeters. I know there's 100 centimeters in a meter, so if I move my decimal 2 places to the right, I'd get 10 centimeters. The wall thickness was 0.18 times 1 over 15 will give me 0.012 meters, or 1.2 centimeters. And then 2.5 was my last dimension, times my scale factor to get my image size of 0.167 meters. Move the decimal 2 places, or 16.7 centimeters. Now, we want to draw this. Again, you would have your straight edge, which would be a lot more accurate. I'll get the ruler out here to just try that out. So I have a diameter of 10 centimeters on this new one. So about 10 centimeters. Again, try to be as accurate as you can. I have a wall thickness of 1.2 centimeters. So if I move this over 1.2 centimeters there. And on this side, just move it to the 11 and say 1.2 is the thickness of the diameter. I'm using my compass just to make a circle around that point for that diameter. This is more accurate. And then the other point So using a compass or ruler. Again, it didn't go through my ticks, but because I moved the whole thing over. So this thickness should still be 1.2. Yes. Okay. Now what we're missing is just the length, which might be hard for us to see in this view. Get rid of my my compass. So I need a length of 16.7 centimeters. So I've tried to line it up as best I can, but the length of this pipe, oh, of course I'm moving everything else now. Will be 16.7. That overshot, so let's say about there. And we'd want to do the same thing underneath. So just trying to show what a scale drawing of that would be. So this is hard. You can probably do a neater one in your books. But that's just, if it says draw, we really do need to draw. Just using the scale. So we used our scale factor given, multiplied it by our object's original size to get our new image. And then using a straight edge, protractor, compass, whatever you need to use there to sketch what that pipe would actually look like. All right. Your assignment is on page 497. Numbers 1 to 4, 8, 9, 11, and 14.